Hello everyone, my name is Eduardo Silva, and today I'm here to share our experience about how to handle logging in Kubernetes. And everybody knows that logging is not the more fancy thing, meaning that logging by itself is boring, right? You don't have dashboards, colors, or things like that. Nobody wants to do logging, but you need it. When your application crashes, or you have some high load, or your application is not responsive enough, you need to do some kind of troubleshooting. And that's what it's logging for. And in Kubernetes, things get a bit complex. Okay, so that is this presentation about. My name is Eduardo Silva. I'm a principal engineer at this company. We used to be called Treasure Data. Now we are part of ARM. And I'm a maintainer of a project which is called Fluent Bit. And Fluent Bit right now is a project that I just realized this week that is being used a lot in China by WePay, Cloud2Go, and many Kubernetes service providers. And we are interested in logging Kubernetes, Docker, and everything that's related with performance and Linux. So before to start talking about logging in Kubernetes itself, we need to start learning about how applications works with logging and the whole interactions. The most simple logging stuff is that when one application triggers a message, and that message goes to a file, and that becomes logging. Okay, and if you are familiar with Unix or with Linux in general, you know that every program has at least 3 stream interfaces, right? The input, the standard output, and the standard error. And these interfaces are really important for the container ecosystem. Oh, I pushed the wrong button. That's a light. So logging happens mostly here in the standard output and the standard error. So that is one way that applications can start sending some messages to the outside saying something is happening with my application, or maybe something is missing or something is wrong. Okay, now how this works in logging with Docker containers or with containers in general. Your application triggers a message like, hey, Shanghai. But that message is not just the hi, right? It has a timestamp, a time when this message was created, and also one stream. Oh, sorry about that. A stream from where this message was created, and well, the message, the stream, and the time itself. And that message is stored in the file system. And the file system, I mean a path which is var lib docker containers, the container ID, the hash, and then you get a JSON map message in the file system. And of course, if you want to do some application troubleshooting, I'm sure that you don't want to go to the file system and look for that file, because that is a pain. If you have 100 of containers, you have 100 of different log files with different hashes, and you don't know what that means in general. Okay, so when working with logging and containers, you have to understand that if one application generates a message, that message goes to the file system. And then if you're going to do logging, you need to understand where these logs are stored, how to read them, and look up for the specific fields inside the JSON map, which is log here, to get the real message. And of course, sometimes you would like to append some metadata to that message. So, a very quick hands-on here to understand how this works. Of course, this is not the way to do logging. But for example, I'm going to run a simple container which is called busybox with a message, hey, Shanghai. So if Docker works, because I'm behind, I don't have access to the Docker registry. Well, that would be a problem. Oh, it worked for some reason. So what we got here is a container ID. This is what's happening behind the scenes. Actually, you don't need to care about this. but it's good to understand how it works, because you can improve that in the top level. So we copying that hash. If you go to the file system, I'm going to become sudo cd var lib docker containers, and then I paste the hash. I'm here. This is my container environment. There are many files, and one of them is the log file. I copy the file, cut. There you go. Well, if you want to see more pretty, that's a message. Okay? I triggered a message on the command line, and that message was stored in the file system in a JSON map, and then you got it there. But of course, you don't want to do that manually. Okay? So, how this is correlated with Kubernetes? Before to dig into logging, we need to understand how Kubernetes works. In Kubernetes, you have one application, or at least from your perspective, you want to deploy one application. This application will be deployed in a container. That container is inside a concept which is called a pod. And a pod, as you can see, can have many containers, which means multiple applications. But in a Kubernetes node, which can be a bare metal machine or can be a virtual machine, you can have many pods. And a cluster is composed by many nodes, plus your application server or the master API server. So if you think about this, if you're going to do logging on this, you have logs from this container, this other, which belongs to this pod, to this node, on this cluster. So it's not so simple. It's not just the container ID and my log. So how logging and its context works in Kubernetes? I said we have the application, we have the containers, we have the pods, and the node. And each one of them has a lot of data that allows us to understand what is the context of the application that is running. Because for a log message, you want to understand what is from a log, I want to know what is the pod name, what is the namespace, what is the host name, what are the labels in Kubernetes, and annotations. Okay, not just the message. So, as a context, we take all this information, the container name, container ID, namespace, node, and so on. And that is something that needs to be solved by a logging processor, because you don't want to do that manually. It will be a pain. And from a context, you can say, okay, from where I'm going to get this context for this application that is generating some log files. The first one, like part of the context, like for example, the pod name, the namespace, and the container name comes from the file system, where it's running that container, where it's running that application. But there are more information that is outside of the context of that node. And that information is inside the Kubernetes master or API server. So what that means, that when your application generates a message that is logging, in that node you understand that that message belongs to that node, to that container, that application. But you don't know what are the labels of that pod, what are the annotations of that pod. Because with that information, you can do the fancy thing which is called data analysis. Because at the end, logging is just like a tool to collect data and aggregate data in just one central place, because your end is to do data analysis. And for that, you need to have a log processor. Right? Without the right tooling, you cannot do like the old way, SSH into a node and start looking for the container logs. It will not work on that way. So when you have the log processor working inside your Kubernetes cluster, then you go to your real end. And your real end is aggregate and store that information in one central place, your database, a cloud service, or whatever you're using for your own needs. So log processing in Kubernetes is like this. This is a node where I'm running two pods or two applications. Okay? And these applications are generating some login messages. Those login messages are being trapped by the container engine and being stored in the file system. Okay, this is one way to work. Some Kubernetes clusters use systemd with the journal service, but here we're using how it works with the file system. And then what you do is to run a daemon set with the log processor. Do you know what a daemon set is? Are you familiar? Okay, some of you. You have a pod. The daemon set is a pod that runs on every node of the cluster. That's it. Okay? So you make sure that your logging processor will work on every node that belongs to one specific cluster. And then you let your logging processor start consuming the log files that are being stored on that node. At this part, we have just one part of the context, right? Container ID, container name. But then we need to get more information for this every log entry. And that comes from the API server. So the logging processor, what it's doing is going to the file system first, and then go to the API server and merge all that information, and then deliver that log outside to the database or the cloud service. So the simple message that we generated at the beginning, that actually was "Hey Shanghai," and then it appended timestamp and the stream, becomes something like this. And with this information, you get the real context, because in your database, which can be, for example, Elasticsearch or InfluxDB, you can say, please show me all the logs that the pod name belongs to, well, I put Open Source Summit, but it's KubeCon, or which the host belongs to Minikube. And that is really relevant, because your application, you know that in Kubernetes, you deploy one application, but the application actually, it's hard to know at the beginning in which node it will be running. And if you create many replicas of that application, maybe it will be distributed across different nodes. And then you need to centralize all that information to be able to query for specific patterns on the log that was generated. So as an example, we are going to use a local Kubernetes cluster and running here with the log processor and ingest the data into Elasticsearch. Are you familiar with Elasticsearch? Kibana? Cool. Okay, so this is the thing that you don't want to do. Okay, so let's check if I'm running my Kubernetes. If it's everything in order. Okay, all pods are running in my local cluster. Now I want to make sure that the database is up and running. This is a local environment. You don't want to do this in production. Okay. Okay, Elasticsearch is up and running. Now I'm going to do something that you should not do at home, which is delete the whole data of the database. Ready. And now I'm going to run a command to query the Elasticsearch index. This is just for the demo purposes. Curl minus is silent mode. Watch typo. Okay, the database is quite empty. What I'm doing here is just querying the database index and try to see how many records do I have in the database. Okay? Okay, so getting back to the Kubernetes cluster, can you read the screen there? Can you read it? Right? Okay, cool. What I'm going to do, if I'm going to the default namespace, there are no pod runners. But here I have an Apache pod like example, that what it does, it just generate. So it's not Apache itself, it's a pod that generate and simulate Apache logs. So what I'm going to do is to run this pod in my cluster and see how it's working. Okay, kubectl logs, Apache logs, follow. Okay, I see that my pod is generating a message every second. That is totally random. Okay, that's when I'm looking at the logs from a specific pod of the cluster. But my goal is to ingest that log where? Into Elasticsearch. So what I'm going to do now is to deploy Fluent Bit, which is one of the logging processor tools that we are using. I'm not sure if we have the config map in the system, but let's try. We are going to ingest the configuration, but it already exists. So we are going to run the daemon set. Let me show you the daemon set. It's quite simple. So the daemon set is just a spec file that you can get it from the project website, from the documentation, and it basically runs this image and makes sure to mount the log files from the node. That's it. Okay, so kubectl, kubecontrol, create, service account is created. Okay, get pods. Okay, Fluent Bit is running in my node, and as I can see now, in Elasticsearch, the number of documents is growing. 97, 98, 99, 100. That means that in my local Elasticsearch, I'm receiving the whole messages that are being generated in the Kubernetes cluster. And now we're going to run Kibana, which is the visualization tool for Elasticsearch. And so there is Kibana start. Okay, I'm going to load this index using the timestamp. Okay, let me try this. Yeah, that looks better. Okay, so here we can see that the logs are coming to Elasticsearch in a better way. Okay, that is the first part. So we solved one of the problems, how to collect the logs from different nodes, different pods and containers, and aggregate them back in one Elasticsearch. And then we can do some kind of visualization. For example, let's look at this record. We're going to look at the JSON map. If you look carefully, you will see that the whole log is here. We have the timestamp, we have the log, the string, the time, and then, if you look carefully here, we have the, I'm going to unselect to make it more readable. Here we have all the Kubernetes, oh, I just lost it here. All the Kubernetes metadata, pod name, namespace, pod ID, labels, the name of the application, and so on. The host, the container name, all this information. And if you understand what we did just from an application perspective was just to trigger the message that is here. And that message got the whole context that belongs to a Kubernetes application. Okay, until that, it's fine. Okay, we understand how it works and we're good. But if you can say this message, you can understand it. If you read Apache, the Apache logs, you say, oh, this is an IP address, this is a timestamp, this is a HTTP method, the address, the protocol version, and at the end, the status code. But for a computer, it's not like that. For a computer, that information, it's just a string of bytes, an array of bytes. That's it. It's no more than that. So if you want to do some kind of data analysis and process thousands of these messages, it will take some time. So how you can improve that is try to convert that unstructured message to a structured message. So we are going to, I'm going to show you now a different pod that we have here, which is called Apache Annotated. The difference of this pod with the other pod from Apache that we just deployed is that we have a special annotation which says Apache. That is a specific Fluent Bit feature which is saying when deploy this pod and Fluent Bit get the pod logs and go to the API server and get the annotations, it will find this option and it will say, oh, this application is using the Apache format. So I'm going to apply my own parser for Apache. And then the result will be totally different. Let's deploy this pod. Okay, it's up and running. And if we look at the logs of this pod, it's the same thing. It's the same thing that the other, but the only difference is that we have one annotation at the Kubernetes level of that pod. But what happens here, okay, I'm getting more messages, like 2 per second, which is right. And now let's get back to Kibana. Here. So I'm going to show, I want all the Kubernetes that pod name equals Apache, this one. I'm going to query all the logs that belongs to the new pod that I have just created. And let's look at an example here. If we go to the JSON map of that specific message, okay, there's a difference. The log file, the log message, is pretty much the same, okay? But now we have a new structure here it's called parsed log. You can change that in the configuration. And that change, if you look carefully now, it says, oh, this is the host 142 something, which belongs to this part. User ID is not set. The HTTP method, which is this one. The path. Status code, the size, referred agent. So with a good log processor like Fluent Bit, you can, from a Kubernetes perspective, you can improve how you are doing logging, because most of your applications that you deploy have different formats, not just a JSON map. Sometimes use Nginx is different than MySQL format, and all applications are different. So the thing is that under your log processor, on this case on Fluent Bit, we just add different parsers for different needs, and you can create your own parsers. Okay? And then in the pod, you just suggest a parser, and then you get the information as in a good way, and not just like a string of bytes, an array of bytes like this. So that is the good way to do like logging in Kubernetes. Okay? So, are you familiar with Fluentd? Not Fluent Bit, Fluentd? Yeah. Well, Fluentd is a CNCF project. Right now, we are in the incubation phase. We are working towards graduation, and we are just missing the legal part, which is, review the trademarks and assign trademarks to Linux Foundation. But we are working on that. And Fluentd is the real logging parent project. Fluentd is running everywhere. And the good thing about Fluentd itself is that it has more than 850 plugins available. That is a lot. That does not mean that the core team of developers of Fluentd have wrote 800 plugins. That means that the whole community around Fluentd has done that. And in adoption, Google has an official login agent for their own platform, which is called Google Fluentd. If you go to Microsoft Azure Services or use OMS, their login agent is Fluentd. If you deploy the Kubernetes but in the OpenShift product from Red Hat, the login solution, guess what, is Fluentd. And we are working towards graduation. But when people was using Fluentd was started like 7 years ago. They said, okay, we're running in Kubernetes now, and there are specific use cases where we need more performance. Because they said Fluentd is written in a mix of Ruby and C language. And sometimes I'm sending like thousands of messages per second, and I need something faster than Fluentd, or something lightweight that do not consume too much memory. But one pause, because logging by itself is expensive. It will be always expensive. But you need to find different ways to how to make it better and faster. So 3 years ago, we envisioned this and we started creating a new tool which is part of Fluentd project, which is called Fluent Bit. And what are the main difference between Fluentd and Fluent Bit? Fluent Bit is fully written in C language. So if you are a C developer, you are welcome to join us and try to improve the project. It's made to consume a lot of low memory and CPU footprint. But in terms of plugins, we have just a few, 45, compared to Fluentd that has more than 800, right? Because we are most focused on specific needs. We have built-in security with TLS, and it's currently Kubernetes ready. So you can enrich the logs. I just show you how to ingest log from Kubernetes to Elasticsearch and filter all the data, and can parse the structured messages from one place to another. Well, this is like the white version of the pod definition. So if you're deploying applications in Kubernetes and you are using Fluent Bit, just use the annotation, because that will save your life, or your job life. And also in Fluent Bit, it's important monitoring, because if you're running a cluster, you want to monitor everything. Not just the application, but also the application that does logging. So we expose a Prometheus endpoint where you can see how the data, how the logs are flowing on that specific Fluent Bit node that is running on that Kubernetes cluster. And also, if you would like to do some kind of filtering meaning I want to, I have this record, I would like to remove some keys, add new ones, or information that is mostly important for my business. Like a few months ago, the only way to do that was write a plugin in C. But write a plugin for filtering takes time. And make it right takes more time too. So we come up with a solution when now you can run or create your own filters using the Lua language. Are you familiar with Lua? Well, it's a scripting language that has its own just-in-time compiler. It's really fast. The performance penalty is pretty low. And you can write a simple function that you add as a configuration file, which say this is the tag of the message, the timestamp, and the record. You modify in a Lua table, and then you just return the value that you want. And if you're using Kubernetes, you can add that in a config map, which is even better. So the good news, as you listened in this morning, we are releasing Fluent Bit 1.0 on KubeCon in December, around December, the first week of December, I see. And there are many features that will come as part of Fluent Bit that they are not available. For example, GELF support format. We are coming also with buffering in the file system, because at the moment, the only buffering mechanism of Fluent Bit is in memory, not in the file system, but we are coming up with a new design with an hybrid system, and that will be available shortly. And if you want to contribute or join the project, we have official documentation repository. We have, if you are running any meetup and you want to speak about login, let us know, you can participate. And of course, create more code. Okay, that was presentation, and thank you. We have a few minutes. Hello, can you hear me? We have a few minutes for questions, so please raise your hand now.
So also Kubernetes add-on, cluster that has add-on. Their official image is still Fluentd, not a Fluentd. For the Kubernetes default add-on, it is still using the Fluentd user image. So my question is, when will the Fluentd beta image be put there?
In Kubernetes, we have to understand. He's asking if most of the add-ons for logging in Kubernetes are with Fluentd, and why not Fluent Bit, and when that will happen. That's the question. The thing is that in Kubernetes, the logging is totally external. Logging in Kubernetes is not a core component of Kubernetes. Kubernetes just exposes the logs to the file system, and it's up to you what to use and how to consume the logs. So if you want to use, for example, Fluentd, we have the daemon sets and recipes for Fluentd, and same for Fluent Bit. So it's up to you to decide what to use and when.
So where can I get this Fluentd image, Fluent Bit image, and
yeah, we have images.
Deployment you have, right?
Yeah, we have Docker images of Fluent Bit. Actually, the image has been downloaded or pulled 13 million times in the last 10 months.
Okay. Another question is, I am already familiar with the Fluentd config file. I know how to forward, how to get a source, how to output. So my question is, if I using the Fluentd beta, is there any change for the config file?
Yeah, the configuration is similar, and I would say that it's more simple than the Fluentd one. Oops. So for example, if we go to conf, well, you define a service. Most of them are comments.
Oh.
When to flush, demo mode, log level. And then you define input sections, filter sections, and output sections. And we use the same mechanism between tags and matches.
Something different.
Yeah, it's different. There's two big difference. We don't have like two levels of configuration, so make it more readable. And the other is that the configuration, we have like a fixed indentation, like Python code, that you cannot break. If you write wrong configuration, it will not work.
Okay, final question, quick question is, so you just showed as an annotation, and as Apache annotation, it will give you very beautiful log format. So as we are using the Istio, and the Istio process also provide a very good logs. And can I get this annotation for it for the Istio process?
Yeah, you can define your own parser using regex, JSON, LTSV format backends in a configuration file.
Okay, thank you.
Yeah, actually, most of the configuration that you see here is people who is using Fluent Bit and say, oh, I have this format, and I send a pull request to GitHub, and we merge that later.
Okay.
There are many.
I will define myself later.
Yeah, the thing is that you don't want to look at this every time.
Yeah.
You just define one and then use it many times.
Yeah.
Okay, thank you.
Thank you.
More questions? We have 1 minute.
I want to know when log rotator if there is a log lost or not.
Sorry, would you please repeat the question? The Docker?
When log rotator happened, is the log lost or not?
Lost errors when the data is lost? So if you have Docker and you send the logs get lost? So sorry, I don't understand the question.
When log
Oh, so what happens on log rotation? We solve it. So when a file gets rotated, because the log file is growing too much, what we do is to monitor that file. If a file was rotated, it means that its name has changed. So what we do, we assume that a file was rotated. We continue, Fluent Bit or Fluentd, both do the same thing, continue monitoring that file for a couple of seconds, and then just stop reading on that. And then rescan the whole path for new files, just in case a new file has been created again. So if your system is rotating files, you can use both Fluentd or Fluent Bit. It will work. We don't have more time for questions because next speaker is coming up, but I will be outside if you want to talk more about Fluent Bit. Thank you so much.